Technology rarely reshapes the world overnight. It changes it gradually, until one day, the shift is impossible to ignore. We're in one of those moments now. What makes this era different isn't just how fast innovation is moving, but how many breakthroughs are happening at once. Intelligence, biology, energy, manufacturing, connectivity, and human-machine interaction are all advancing together. When these technologies collide, their impact multiplies. Below are emerging technologies shaping the next phase of society, not as science fiction, but as real systems with real benefits and real trade-offs. Number 12. Artificial General Intelligence. AGI is the idea of a machine that can learn and reason across any domain, not just one narrow task. Today's AI is powerful, but specialized. It writes text, recognizes images, predicts patterns. A GI would be the leap from tool to general problem solver. Research groups often chase this through larger models, better training techniques, and reinforcement learning, systems that improve through feedback, trial, and error. If AGI ever arrives, its impact could be extreme, accelerating science, automating complex work, and reshaping the entire economy. But it also raises hard questions. How do you align a general intelligence with human goals, prevent misuse, and control systems that may improve themselves? Number 11. Solid-state batteries. Solid-state batteries replace the liquid electrolyte in lithium-ion cells with a solid one, aiming for safer designs, higher energy density, and faster charging. If scaled successfully, they could be a major unlock for electric vehicles and grid storage. The challenge is manufacturing, making solid-state cells reliable, durable, and cost-competitive at massive volume. Number 10. Quantum computing. Classical computers process bits as zeros and ones. Quantum computers use qubits, which can represent multiple states in special ways, making certain kinds of computation dramatically faster, at least in theory. One of the most famous milestones was Google's 2019 quantum supremacy experiment on its Sycamore processor, where a task took about 200 seconds and was argued to be infeasible for classical machines at the time. Meanwhile, IBM has been pushing large-scale hardware roadmaps, including processors like Condor and the more performance-focused Heron family, aiming towards systems that are not just big, but useful and reliable. The biggest blocker is still errors. Qubits are fragile, and scaling without noise is brutally hard. But if quantum utility becomes mainstream, it could transform cryptography, materials science, drug discovery, and large optimization problems. Number 9. Brain, computer interfaces, and beyond. Brain, computer interfaces translate neural signals into commands, allowing a person to control a cursor, a prosthetic limb, or other devices using brain activity. The most practical and immediate value is medical, restoring independence to people with paralysis or neurological disorders. Neuralink has publicly described progress toward human implantation and clinical trials, and reporting in early 2026 described a growing number of participants in its trials and ambitions to scale production. The long-term visions, memory enhancement, faster learning, mind-to-mind communication, are far more speculative. But even the realistic version is world-changing. It turns the brain into an interface, not just a biological organ. Number 8. Humanoid robots. Robots are leaving the cage of controlled factory floors. Humanoid robotics aims for machines that can move through human environments, stairs, doors, clutter, and handle general-purpose tasks. The hardest part isn't appearance. It's balance, dexterity, and safe interaction. Modern systems combine better sensors, stronger actuators, and smarter control algorithms to do things that used to look impossible. If humanoid robots become affordable and reliable, they could reshape healthcare support, elder care, logistics, disaster response, and dangerous industrial work. The question is not just capability, it's economics. Can they be built, maintained, and deployed at scale? Number 7. Generative AI. Generative AI doesn't just analyze content, it produces it. Writing, images, audio, video, code. It works by learning patterns from massive datasets and then generating new outputs that match those patterns. This is already changing how people create. But the next stage is deeper: personalized education, interactive entertainment, AI-assisted product design, and faster scientific workflows. The downside is equally clear: misinformation, deepfakes, and content floods that make trust harder. The tech is powerful, but society now has to build the guardrails. Number 7. Satellite internet. Satellite internet constellations promise broadband-like connectivity almost anywhere, especially in rural or underserved areas. The advantage comes from low Earth orbit. Closer satellites reduce latency compared to older geostationary systems. As these networks grow, they could shrink the digital divide, support disaster response connectivity, and expand global access to online services. But they also raise concerns: orbital congestion, space debris risk, and regulatory disputes across countries. Number 6. Artificial wombs, womb. Artificial womb systems are being explored as a way to support extremely premature infants in a controlled environment that mimics key womb conditions. In the near term, the goal is survival and better outcomes for premature births. In the far future, still highly speculative, people imagine broader reproductive options. That future comes with a heavy ethical and legal load: consent, parental rights, inequality, and the definition of pregnancy itself. Number 5. Nanotechnology. Nanotech manipulates materials at incredibly small scales, where physics behaves differently. The promise is enormous: targeted drug delivery, stronger, lighter materials, better batteries, advanced filtration, and next-generation electronics. A common theme in nanotech is better performance per gram: less material, more capability. But it also demands caution. New particles interacting with biology and ecosystems require careful safety research. Number 4. Internet of Things. IoT is the web of connected sensors and devices: thermostats, cameras, industrial monitors, smart meters, constantly collecting and exchanging data. Its power comes from visibility. When systems can measure reality in real time, they can optimize it. That means predictive maintenance in factories, smarter energy use, and personalized healthcare monitoring. But IoT also expands the attack surface. Every connected device is a potential vulnerability, so security becomes as important as convenience. Number 5. Autonomous vehicles. Self-driving systems combine sensors, radar, sometimes lidar, mapping, and decision algorithms to navigate roads with minimal human input. The future impact is bigger than convenience. It could reduce accidents, shift car ownership toward shared fleets, reshape cities around less parking, and transform logistics. But autonomy is hard because roads are messy: weather, edge cases, unpredictable humans, and legal liability. The technology is advancing, but deployment is uneven, and regulation will shape how fast it spreads. Number 4. Space tourism. Space tourism is moving from fantasy to a real industry, starting with suborbital flights that offer minutes of weightlessness and views of Earth. The next steps are more ambitious: orbital trips, private space stations, and eventually, lunar tourism. It's expensive and niche today, but like early aviation, the first phase is not about mass access. It's about building the infrastructure and proving reliability. Number 3. Smart cities. Smart cities use sensors, connectivity, and analytics to manage traffic, energy, utilities, public safety, and transportation more efficiently. When done well, this reduces waste, lowers emissions, and improves quality of life. When done poorly, it becomes a surveillance nightmare. The same technologies that optimize a city can also monitor citizens, so governance matters as much as engineering. Number 2. Mixed reality. Mixed reality blends physical and digital worlds so virtual objects can appear anchored in real space, and users can interact naturally through gestures, voice, and spatial awareness. MR's early wins are training, design, remote collaboration, and retail visualization. Longer term, it could reshape how people work and learn by turning any environment into an interactive interface. Number 1. 3D printing-tive manufacturing. 3D printing builds objects layer by layer from digital designs. Its superpower isn't printing toys, it's manufacturing flexibility, complex shapes, customized parts, rapid prototyping, and on-demand production. As materials improve, metals, composites, biomaterials, 3D printing could decentralize manufacturing. Instead of shipping finished products across oceans, you ship designs and print locally. If you want to stay ahead of what's coming next and understand the ideas that will define the next decade, make sure you like and subscribe so you don't miss what's ahead.